Hey guys, this is Mr. Grahn, 8.3, the law of sines. In this video, we're going to talk about what the law of sines is and then use it to find some missing side lengths. So the law of sines, this is a law that applies to all triangles. So we've done a lot of trigonometry that has to do with right triangles, but what about non-right triangles? Obviously, this is not a 90-degree triangle. A couple of things to start with. Notice how this triangle, sometimes we'll call this the ABC triangle, but notice a couple of things with this, that our capital letters, A, B, and C, these are angles. And then opposite that side, so opposite angle A is side A, which is a lowercase a. So A, B, and C, where they're lowercase, these are the sides. And there's a really good reason for this. All of this equation that we're going to use, this law of sines, it has to do with the relationship of this side and its opposite angle, this side and its opposite angle, and this side and its opposite angle. So these opposite side angle pairs. All right, now what the law of sines says is this, that sine of angle A, if we divide that by the length of side A, so we make that a fraction, sine A over A, that is equal for all three side angle pairs, right? So sine of B over its opposite side and sine of C over its opposite side. And we can actually show this, why this is, pretty easily, pretty quickly too. So I'm going to do that real quick. If we take this triangle and we split it into two right triangles. Now I have a height here, right? That height is opposite angle C. So if we said sine of C, that is our height here, our altitude, that's our opposite side over the hypotenuse B. So we will say that that's h over b. Well, that means that the height, if I wanted to solve for h, I would just multiply both sides by b, and I get that this height is equal to b times sine of c. So lowercase b times sine of c. That's the height right here, okay? Now, if we look at the same thing through the left, or through the right-hand triangle here, we can do something really similar. This height, right, our height, that is opposite of angle B, and so we can say that sine of B is equal to the opposite, which is my height, over our hypotenuse, which is C. And then same thing, if I multiply both sides by C to cancel this out, I get that the height is equal to C times sine of B. So this is also equal to C sine of B. Well, that doesn't really look like my law of sines yet, but both of these little equations, B sine of C and C sine of B, represent the same length. They're equal to each other. So we can say that B sine of C is equal to C sine of B. Well, it's not quite there yet, but what if we do this? We'll divide both sides by B and C. Lowercase b and c, meaning that they're the side lengths, not the angles. On this side, the b cancels out. On this side, the c cancels out. And what I'm left with is sine c over c is equal to sine b over lowercase b, which is part of my law of sines. Now, we could do this with all the other pairs too, but that'd be a little time-consuming and redundant, so we'll just move into some examples. Okay, so using the law of sines to solve this, we want to find the length of yz to the nearest tenth. Okay, so yz is right here. Now, I'm going to relabel this. I don't like yz in here because that doesn't look like our law of sines. I like a lowercase x right here because that's opposite this side x. And I like a lowercase y right here because that's opposite angle y. That's a better way to label this. Okay, when we're using the law of sines, it's all about the opposite side angle pairs. I have that this is a 77-degree angle and this side length is 7. So this is one of the pairs from my law of sines. I can start this out by saying this is sine of 77 degrees over 7. That's one of my fractions, right? The other one, now I'm looking for side x, so I need to use the angle that's opposite side x, which is 51 degrees. So my other one, sine, make that a better sign, 51 over lowercase x. Now I can cross multiply to solve this. When I cross multiply, on one side is going to be x sine 77, right? X times sine of 77. The other side is going to be 7 times sine 51. Whenever I write these, I always like to put the number, like the plain number or the x in front, because then it's less likely that I goof it up in the calculator later. All right, now I'm solving for x. Let's divide both sides by sine of 77. Now this is a lot to put in the calculator, but it's doable. I'm going to rewrite this exactly how it will look in a TI-84 or 83 calculator. It would be the top part, 7 sine parenthesis 51. Really important that we put the end parenthesis on this before the division, and then sine 77 in parentheses like that. Now when I plug all that in, and I'm double checking that I'm in degree mode, this is actually the second time I'm recording this video because I got all the way to the end before I checked that I was in degree mode. So if that ever happens to you, don't worry. Don't feel too bad. It happens to your math teachers sometimes too. All right, and if I plug all that in, I get to the nearest tenth that this is going to be 5.6 for my side length. All right, next one. Very, very similar. Now, as we go along and we look at some different types of problems, we're going to have to be able to recognize when we use the law of sines. And we use the law of sines almost exclusively when you have an opposite side angle pair either given to you, or you could easily find the missing side that would be opposite of it. Okay, so RST, we're finding side RS. Don't like RS. Let's put a lowercase t, right? R to S, that's actually side T in this case. Lowercase s over here. 9 is our lowercase r. That looks better now. So one of these is definitely going to be sine of 63 over 9. All right, now I'm looking for RS, which is actually T, right? I'm looking for this side. That's opposite this angle. Well, I don't have any information there, right? Except I kind of do, because I have two angles. I can easily figure this one out. I don't need any trig for that. It's 180 minus 63 minus 42. And that would be the same as 180 minus 105, which is 75 degrees. So angle T is 75 degrees. All right, then that is my other side angle pair. So sine of 75 over T. And then when we cross multiply, we get T sine of 63 equals 9 sine of 75. We can divide both sides by sine of 63. Right, that cancels out. And now we've got T is equal to 9 sine 75, making sure that I've got the parentheses around it, divided by sine of 63. And that is 9.8. Like that.